In section 10.3, we're going to talk about two types of probability: experimental probability and theoretical probability. So let's start off with our first key idea, which discusses what experimental probability is. So here it is. Let's make that there. There we go. So experimental probability. It is the probability that is based on repeated trials of an experiment. Pretty obvious. Probability that's experimental means you've done an experiment. So you have trials. So here's how you figure it out. The probability of the event would be equal to the number of times the event actually occurred over the total number of trials. So this is something that you've actually done. So in example 1, finding an experimental probability. The bar graph shows the results of rolling a number cube 50 times. So here we go. Rolling a number cube. This is how many times we landed on 1, landed on 2, and so on. What is the experimental probability of rolling an odd number? So the probability would be written as P of an odd number equals. So how many times does an odd number occur? Now remember, this is not actually figuring out 1/2. You don't look at this and say, oh, well, there are 6 numbers, 3 of them are odd, so therefore it's 3/6, which is 1/2. So I want to know how many times did it actually occur? Well, it occurred 29 times. If you added up an odd number, 1 occurred 10 times, 3 occurred 8 times, and 5 occurred 11 times. So if you added that up, you would get 29 times that an odd number occurred, over a total of 50 total rolls. So the experimental probability would be 29 fiftieths. Remember, you could also write it as a decimal, which would be 58 hundredths, or as a percent, which would be 58%. Now, when you are given an answer, if it doesn't say what they want the answer as, you could give any 3 of these and it would be correct. All right, so making a prediction. The prediction is this. It rains 2 out of the last 12 days. If this trend continues, how many rainy days would you expect until April? Find the experimental probability. So we want to know the probability of it raining. So what do we know? It rained 2 actual days out of 12. So that means the experimental probability is 1/6. Now to make the prediction, we have to multiply the probability of a rainy day by the number of days in April. So we know 1/6 of 30 days in April gives us 5 days. So we can predict that there are going to be 5 days in which it'll rain in April. Now, theoretical probability is our next key idea. So when all possible outcomes are equally likely, the theoretical probability of an event is the ratio of number of favorable outcomes to the number of possible outcomes. So this has not actually happened. This is theoretical. So if I gave you example 3, you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So our probability of choosing a vowel, well, the favorable outcomes, there are 3 vowels, E, E, and O, and a total of 7 letters. So the probability of choosing a vowel is 3/7, or if you wrote it as a percent, is approximately or about 43%. Really easy. In example 4, we're going to talk about using theoretical probability. It says that the theoretical probability of winning a bobblehead when spinning a prize is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel? So we want the probability of a bobblehead. Now, the number of bobblehead sections are 3. We want the total number, which we do not know. So we know 1/6 equals 3 over x. We can cross multiply, and that gives us 18, because 3 out of 18 is the fraction 1/6. So there are 18 sections on the wheel. In example 5, we're going to compare theoretical and experimental probability. Now, this says this bar graph shows the results of rolling a number cube 300 times. Obviously, if you're rolling a number cube 300 times, you have a lot of time on your hands. So what is the experimental probability of rolling an odd number? So we want the experimental probability. Well, an odd number, that would be 48 plus 50 plus 49, which will give us 147 times divided by 300, because there are 300 rolls. But obviously we need to simplify that. That would be 49 100ths, which is also equal to 49%. So either one would work. Now there's another question though. The next question, which is question B, says, how does the experimental probability compare with the theoretical probability? So when we look at this, we want to know theoretical probability. Well, the theoretical probability of rolling an odd number was 1/2, because it doesn't matter how many times we roll. We're not talking about an actual event. The theoretical probability means we have 3 odd numbers out of 6. That's 1/2. So 1/2 is 50%. How does that compare with the actual experimental probability? Well, the experimental probability is 49%. So you could say that it's almost the same. So the experimental probability is close to the theoretical probability. So that's what you put as your answer. You would write down that they are very close, or that they are very similar. Now then, C says this. Compare the experimental probability. So once again, the experimental probability for part A in example 3 was 49%. But in part A was only out of 50 trials, and that was 58%. So compare it. What you would say would be this. As the number of trials increased, the experimental probability decreased. So it became closer to the theoretical probability of 50%. And here's our answer. As the number of trials increased from 50 to 300, the experimental probability decreased from 58% to 49%. So it did become closer to the theoretical probability of 50%.